Well, so everybody has their file open, I hope. And what we're going to do is to chart our solar path on this example models. This one right here already has a 30 by 30 by 30 cube. I separated the base from the walls and the roof, so that we could use this as an example for your worksheet, okay? And there is already a pedestal and the sculpture thing written on here or drawn on here, and we could, like I said, we could use that as through our exercise. If you note, on this thing, we have a top view of that cube that we just drew with the top view of that pedestal, sculpture pedestal, and then we have a circle with the little crosshair line here. It does say N right here, which means north. If you recall, on our earlier thing, we said we need to find the longitude and latitude. And we did find out for Mount Sac is 34.0487 north. Basically, that's north of the equator. And then switch back. Where is that? Oh, and then to the west, it's 117.884 degrees from the meridian. Okay, remember when we looked at this thing, we have 0 and then the degrees number up to 180 on this side, and then degrees number up on this side, 15, 30, and all the way to 180. Okay, so when we say west, we're going from to the west side to the west from the prime meridian, 117 degrees. So that's what all that is supposed to mean. So we got this number. Where is my, okay, through the longitude, latitude. Okay, and then these numbers are what we're going to plug into, or we could plug into the Sun Earth tool over here. Okay, and to do that, we do have to be careful about the way we plug in the number. If you see this example right here, it's not really an example, but if you see this these set of numbers, it does look a little bit different from what we found out as with the north degrees north and degrees west, right? So when we plug into the Sun Earth tool, we have to say 34.0487 comma. We don't need the degree sign or degree symbol. We just say comma negative 117.84. No degree symbol, no west. Okay, that's already basic telling me by going to the negative direction, it's heading west of the prime meridian. Okay, so what we're going to do is take this number and plug it into, if you didn't plug in Mount San Antonio College and you know where the longitude latitude is of a certain site, because you could take your Google Earth, put a pin on it, and it'll tell you what latitude, longitude it's on. So as long as you have these numbers, you'll be okay. And so you format the longitude, latitude in this way, okay, with a comma, and plug it in. Once you do that, you will get all of these information about, when you plug in what time of the day you want. You will have information on the sunrise azimuth and the sunset azimuth, and the elevation, which is the altitude of the sun on these particular days. Okay, so the sunrise AZ, which means azimuth, I abbreviated, it means azimuth. And I always spell that incorrectly anyway, so so what that means is that it says here in the spring equinox, it is 89.35. Okay, so the sunrise is going to happen at 89.35 degrees. So from the north, we're going to measure down to 89.35 degrees. So all intents and purposes, it's going to be 90 degrees. Remember, it's 90 degrees this way, and then 90 degrees, 180, 270, and then 360 is back to 0 again. So I would like for you to understand that sunrise is going to be from the east, okay? And the sunset azimuth is 270 degrees, basically due west, okay? And then the elevation right here is at high noon, and your sun earth tool will tell you, how many degrees that is in high noon on at how high where the sun is relative in degrees to your center of the project. Okay, so if we have all these numbers collected, like I said, just like Nadine wants you to collect all of the sun diagram, sun charts, get all of these information and jot it down somewhere. I jotted down here so that we could all kind of work together on it. And for the homework, I think we should, since the homework says find the rest of it, and I already kind of gave you this already, we should probably just do you should probably just research the La Jolla site. That might be a good compromise of that.
La Jolla?
Okay. La Jolla, our solar gallery site. Okay, so we could go ahead and let's just ignore the fall equinox and the spring equinox and concentrate a little bit on the summer and the winter solstice. Okay, so the longest day and the shortest day. For this, for the summer, we're gonna try to find the sunrise azimuth using this wheel right here. So what we're gonna do is to rotate this line 60.66 degrees. To do that, don't use your gumball, because if you use your gumball, it's going to find the center of your line and then rotate from there. It's just, right? We don't want to do that. So we are going to use the command rotate. All right, so rotate. Or another way to find rotate is, I believe, this tool right here, rotate 2D. Rotate 3D is a completely different thing, so we want to do rotate 2D for now. We will be doing rotate 3D a little bit later, okay? The rotate 2D is your left mouse button. We're gonna rotate this line from the center of the arc, or center of the sphere, center of the circle, to whatever degrees that this says it is. The other rotate is, I believe, in edit, right? Nope. Yep, nope. Where's rotate?
Transform. Rotate.
Ah, there it is, rotate. Yeah. Okay, so I don't use the pull down, so I don't remember this too much, but remember, if you use the help tool, it'll always find other ways of doing it. So rotate, I'm going to type in rotate, enter, select the object to rotate. I'm going to select this line, enter when done, copy no. Why don't we say copy yes, because I want to keep this line where it is. Okay, and then it asks me center of rotation. What you want to do is plug the center point of the circle or the end point. So you could either have end point or center. If you want to select center, you'll have to select the circle to find its center point. But since I have the end point of the circle, I'm just going to put the end point. Okay. Angle of first reference point, I'm going to put it right at the north intersection. Okay. And I want to rotate this thing this way. If you notice down here, towards the telemetry stuff, basically it's telling me the rotation in a positive number. Sometimes you'll have it in a negative number, so you have to be careful about that. Rotate. Okay, now it's looking like it's a negative number, but I do want to go 66 degrees, or I'm sorry, 60.66 degrees this way. As I'm turning, it's giving me a negative number there, so I'm going to type in the negative number, negative 60.66, and then enter. Didn't I say copy? Oh, I undid that, huh? Sorry, I'll do it again. Rotate, object, copy, yes. Select the center rotation, select the reference point, and then come down this way and 60.66 degrees. Enter.
Minus.
Oh, I forgot the minus. Sorry about that, guys. I'm screwing up, huh? Try again. Third time's a charm. Copy, yes. Enter the endpoint there, and I'm going this way, and I'm looking at the coordinates, and it's giving me a negative number, so I'm going to type in a negative number, 60.66, and then enter. There it is. Okay. While I'm on here, I could also do the sunset angle too, which is 299.64, because I'm still in the same same number. Okay. So if I do that, I think I could get that number. I'm still going the negative direction. Ah, shoot, I escaped. Let's try it again.
Copy, yes.
Copy, yes, and then negative 299.34, which is my summer solstice. Does that look right? Yes. So enter, and it's giving me that. It generally should be a mirror image from the, with slight variation, it should be a mirror image of your the first line that you drew. It may not exactly be, but it's, all intents and purpose, it is. Okay. So that is my summer summer solstice. To get the winter solstice, same process. I'm going to copy, or I'm sorry, rotate, select the object, enter when done, copy, yes, center of the circle, reference point, and I am going negative, where am I this time? 118.05. 18, oops, I gotta type in the negative. Negative 118.05. Right, yes, and then say enter. And there is my winter solstice using this number. Winter solstice sunrise at that number. Now I'm going to do the same thing for the summer. I'm sorry, for the sunset, which is negative 241.95. Did I type that in correctly? Yes, I did. So enter, and it's right there. So this should also be somewhat reciprocal number, right? The sunset, I'm sorry, the solar noon, let's just assume, there is that number that we can get for the angle of that. It may not always be 180 degrees, but let's just assume it is. Okay, so that I could draw from that point to the quadrant, quad, and it's going to find the quadrant for me. There it is. And so I drew that line right there. This I'm going to need for the elevation. Okay. So for now, if we could catch up with this before we go to the next step, I think that'll be a good point to stop.